Hello, my dear students of BSc First Master. So, welcome to Physics classes by Saramdeep Kaur Sidhu. So, today we will discuss a numerical problem related to force electrical oscillator. So, the problem is show that in a resonant LCR circuit, the maximum potential 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 drop across a capacitor occurs at a frequency omega is equal to omega naught bracket start 1 minus 1 over 2 q square 1 by 2. Here what is omega naught? Omega naught is the angular frequency of undamped electrical oscillator, and that all of you know this, that omega naught is equal to 1 over under root LC. And what about Q? Q is the quality factor. Q is the quality factor and Q is equal to omega naught L by R. Omega naught L by R, where L is the inductance, R is the capacitance, R is the resistance. Clear? Now we have to find out the maximum potential drop. Maximum potential drop across a capacitor. So across a capacitor, the potential drop is equal to Q by C. All of you know C is the capacitance and Q is the charge. So Q in a force electrical oscillator, Q is equal to, we have derived this relation in the previous lectures, that Q is equal to minus iota xi naught, or you can say E naught, you can also write potential drop here, xi naught upon omega Zd. Zd is the electrical impedance, e raised to iota omega t minus phi, where we have done that the phase difference between Q and xi naught, that is equal to phi plus pi by 2 minus, okay, and this lags behind this electromotive force. Now Q, we have to find the maximum value of potential drop. This will be maximum when Q is maximum. Clear this point? This will be maximum when Q is maximum, and when Q is maximum when this will be minimum, omega Zd minimum. So Q is maximum when omega Zd is minimum, and for this derivative of omega Zd with respect to omega, that will be 0. Where Zd is equal to, Zd you know, Zd is equal to electrical impedance, that is equal to R square plus omega L minus 1 over omega C square under root, where R is the resistance, omega is the inductive reactance, and 1 over omega C is capacitive reactance. Clear? Now we have to find out the derivative of this. So derivative of omega, put the value of Zd, R square plus omega L minus 1 over omega C square raised to power 1 by 2. 1 by 2 is on this whole. Now we have to go, now omega we want that it will be inside. So for this, when it goes inside this bracket, it becomes omega square. So R square omega square plus, now omega square means here inside goes omega square L, 1 omega will go, omega square L minus 1 over C square raised to power 1 by 2. Clear? Now take its derivative. The derivative of this term will be 1 by 2. This whole term raised to power minus 1 by 2 means x raised to power n. Derivative of this will be n x raised to power n minus 1. So n is 1 by 2, x is this, n by 2 minus 1, 1 by 2 minus 1, that is equal to minus 1 by 2. Now the derivative of this inside the bracket, the derivative of in the terms inside the brackets, yes, derivative of this term will be 2 omega r square. 2 omega r square. The derivative of this will be 2 into omega square L minus 1 over C, clear, this term, into derivative of this term. Derivative of this 2 omega square L, derivative of omega square L is 2 omega L. 2 omega L and 1 over C is 0. So this is equal to 0. Clear? So this is the derivative. Now this will become minus 1 by 2. When goes down, it goes with 0. So we have only this term remaining. So remaining term is 2 omega r square plus 2 omega square L minus 1 over c into 2 omega L. This is equal to 0. 2 omega r square plus 2 omega square L minus 1 over c 2 omega L, that is equal to 0. Now taking 2 common, when we take 2 common, omega r square plus 2 common, 2 goes, so omega square L multiplied with 2 omega L, it becomes 2 omega cube L square, omega cube L square into 2 minus 2 omega L by c, this is equal to 0. 2 omega, 2 goes, omega r square plus 1 2 common, taking common, it goes omega square L into 2 omega L, that is 2 omega cube L square minus 2 omega L by c, this is equal to 0. So taking this whole terms in one side, omega square plus 2 omega L taking omega common, taking omega, 1 omega is common, so that will not be equal to 0, so taking omega is not equal to 0, omega taking common, r square plus 2 L square omega square minus 2 L by c, that is equal to 0. Taking 1 omega common, r square plus, go slowly, plus 2 L square omega square minus 2 L by c, this is equal to 0. Now omega can't be equal to 0, so this term will be equal to 0. So taking this term will be equal to 0. What we get? We get that omega r square plus 2 L square omega square minus 2 L by c, this is equal to 0, or 2 L square omega square, this is equal to 2 L by this term, taking this in this side, left hand side, and taking this at right hand side, 2LC minus r square, or omega square is equal to 2L by c multiplied by 2L square, ठीक है, divided by 2L square minus r square over 2L square, over 2L square. So 2 goes with 2. This is c L square. So 1L goes with 1L. This is 1 over LC minus r square over 2L square. Now we have to make this. We have to make this term from this term. We can make this by taking this results, that we know that yes, omega naught is equal to 1 over under root LC. 1 over under root LC, or omega naught square is equal to 1 over LC. So taking this term omega square, taking 1 over LC, put the value of first taking 1 over LC common. So when we take 1 over LC common, what do you get? 1 over LC we take common, what you get? 1 over LC, that is equal to 1 minus r square over, or you can put from here, first of all we put from here that from this term Q is equal to omega naught L by R. So from this term you have the value of QR by L, that is equal to omega naught, that is equal to omega naught. QR over L, that is equal to omega naught. So this implies R by L, that is equal to omega naught by Q. Omega naught by Q. So put here values here. 1 over LC, from this 1 over LC is omega naught square. So put omega naught square minus R square over L square. 1 by 2 R square over L square is omega naught square over Q square. Clear? So this will be taking omega naught square common. What will be 1 by 1 minus 1 over 2 Q square. So this is our result. ठीक है? or you can say omega is equal to omega naught 1 minus 1 over 2 q square raised to power 1 by 2. So this is the potential drop across a maximum potential drop will occur at this frequency. So thank you very much.